Hey guys, we're going to do a little video here on geometry and knives. It's something that you hear people talk about is geometry. What do they mean? Well, the main thing they're talking about is the angle of the cutting edge and the body of the knife. If you talk about various types of grinds, you're also talking about geometries. There's two parts to that. There's going to be the primary grind and then the sharpening bevel or secondary grind, like that. There are many different versions of this. The first one being, most common being flat grind or full flat grind. So you have a full flat all the way to just behind the cutting edge. And then this would be sharpened on a secondary bevel. The next most common is probably the hollow ground edge, where you have two radiuses that are intersecting, like this, and then the secondary bevel. And these can be broad radiuses, like this, or they can be narrow, tight radiuses, like on a straight radius. The third most common is what's called a tunnel grind or mooring grind, which is partially a flat grind with a convexing radius. And these can be all the way to the zero edge or with a secondary bevel, either way. These are the three primary grinds. You also have what's called a saber grind, which is a half height grind, where you would have the body of the knife, and then you'd have a grind like this. And with a saber grind, you would have a secondary bevel. There's a version of this called a Scandi grind, which would be full to zero, or almost zero and rounded in. There are several Japanese grinds that are a little bit more complex, where they have they're non-uniform side to side. They're asymmetrical, where you would have a hollow on one side and then maybe a flat or a convex on the other side, or a saber grind. But all of these different grinds are designed to do different things. For instance, the tunnel grind is very, very robust. The idea is you're putting as much meat right here as you can get, and letting whatever else happens. This is a great edge, or your geometry right, if you want to have an axe or a chopping blade, where you want mass behind the edge and you want weight, because this is going to enter something and force it apart. Now, the exact opposite would be the hollow ground, which is not a great edge if you want to chop something. These do best at things that are slicing or shaving or scraping, because you're very, very thin behind the edge, which means it's not terribly robust. But on the other hand, it is very, very sharp and cuts very quickly and easily. The happiest medium for me is always the full flat grind. The full flat grind tends to have the least amount of material behind the edge, but also have enough mass to hold up to abuse. The version of this I use is sort of a mixture of these two. I tend to do a convex on the last, maybe third of the knife blade into a very short secondary bevel of maybe a 32nd of an inch. This is my preferred geometry, and I adjust this geometry depending on the kind of knife I'm making. If I'm making a chef's knife, I will take the whole geometry, the whole knife down to say, before I round this in, this dimension would be, about that, 20 thousandths or so. And before I sharpen it, after I've radiused this back for maybe a third, this dimension here would be 0.05 or less. Now, the reason I go that thin is that this will cut. The 5 thousandth thick edge isn't sharp, but if you try to cut a potato or a carrot or anything in the kitchen, it will actually sever it. Not nicely, but it will sever it. And it's probably sharper than most people's kitchen knives. So even when this knife is dull, it'll cut things. And that's kind of the point of that geometry. But the reason that I do these complex curves, especially on chef's knives, is that I want a little bit of meat behind the edge to support it, but also to help force the cut apart. And then I want to suck back in flat. And what that does for me is it allows the material I'm cutting to separate away from the edge and not get stuck and bind in the cut. We'll go over kitchen knives a little bit more detail in another video, but that's the basis idea of this. And when I do a chopping knife, like if I do a camp knife or something like that, I tend to keep this a little bit more robust. And maybe I go, 35 here. And then, then I'll still take it down to 7 or 8 thousandths, but I only go up maybe a quarter of the way up the blade, so that my geometry looks more like this, you see, and just thicker. And that gives me a little bit more strength in my edge so it holds up better. The thing is all of these need to be balanced with what you're doing for a heat treat. If you look at this and use this this is the only portion of how you adjust the knife's performance, it'll fail. You need to balance this with the heat treat and the steel choice. When you get those three factors together, they tend to make a much stronger, more robust knife that will perform to beyond most people's expectations. As a general rule, the thinner the geometry is, the harder the knife can be, and the more abuse the knife is going to take, the thicker it needs to be and the softer it needs to be. So I hope that was helpful, guys, and I'll get back to you next week with kitchen knife geometry.